Hello Algebra 2 students, here's the second video for section 3.6. We're going to use the rational root theorem on a word problem. Yay! A storage company is designing a new storage unit. Based on the dimensions shown, the volume of the container is modeled by the polynomial v of x equals 2x cubed minus 7x squared plus 6x, where x is the width in feet. What are the dimensions of the container in feet if the volume of the unit is 154 feet cubed? Here we go, x times x minus 2 times 2x minus 3. This is not a real life problem, but they're making it into a math problem. First of all, since the volume is 154, we can set the polynomial equal to 154, and now we have 2x cubed minus 7x squared plus 6x equals 154. We want to subtract 154 from both sides to get it to look like this. To get it to look like this bottom equation here. And now we want to find out what could the dimensions be, so we need to use the rational root theorem. So we're going to find the factors of 154, which are all these numbers, and the factors of 2, which are positive or negative 1 and 2, and any combination of, I don't like what they did there, any combination of these orange numbers divided by the blue numbers could be possibly a root. We'd have to test them out using synthetic substitution. I like to choose 1 and negative 1 first, and then I like to go to 2 and negative 2. I don't like to deal with fractions, but this list all the possible roots, eliminating repeated values, use a spreadsheet. Yeah, so they're telling us to use a spreadsheet or a calculator, which we could just figure out what the root was. Turns out 11 over 2 is one of the roots. So they plug in negative 11 over 2. Now they said 11 over 2 is a root, and now they wrote negative 11 over 2. I think they meant positive 11 over 2 for here. Because in synthetic substitution, when they bring down the 2 times 2, it comes out to 11. Negative 7 plus 11 is 4 times positive 11 over 2 would be 22. So they miswrote this again. This is the third mistake I found in this unit by them. Anyways, it comes out to 0. So yes, 11 over 2 is a factor. So you can write it as x minus 11 over 2. Remember, if 11 over 2 is a factor, that means if 11 over 2 is a root, then x minus 11 over 2 is a factor. And you can write it like this. They did the quadratic equation, released the discriminant on this, and found that it was negative 208. So they knew that 11 over 2 was the only root. 11 over 2 is the only real solution to the problem. So they stuck 11 over 2, or 5.5, in for x here, and got the width was 5.5, and this is 3.5, and I don't know what that comes out to. 8. The height was 8. All right, not crazy about that problem. This one, also not too crazy about this one, but let's give it a shot. What they want us to use is the rational root theorem. A jewelry box measures 2x plus 1, 2x minus 6, and x inches tall. The volume of the box, 4x cubed minus 10x squared minus 6x, and it turns out the volume is 28. So they want us to find what's the height. Okay, you can give that a shot if you want. Click pause. I'm going to go to it. Well, I have to have this expression equal, or it equals 28. Then I need to subtract 28 from both sides to get it to be into proper form. 4x cubed minus 10x squared minus 6x. I don't know why I'm doing all this. I could have done it a lot faster just doing it up above, but equals 0. Now, to find out what's going to be a possible answer, it's all the factors of negative 28 divided by all the factors of 4. So I have positive or negative 1, positive or negative 2, positive or negative 4. What else can go into 28? Positive or negative 7, positive or negative 14, and positive or negative 28. I knew these last three because if it's 1, 2, and 4, I can divide this by 1, 2, and 4 and get these other three numbers. Okay, all of those numbers possibly divided by factors of 4, which would be positive or negative 1, positive or negative 2, and positive or negative 4. Now, like I've said before, if these are my possible choices, I like to stick to, like, I would test out 1 to see if it's a root, or maybe positive or negative. We change colors for effect. Positive or negative 2 for a root. It turns out I think that the answer is 7 over 2, and that's one I would not try that one right off. But 7 over 2 is the only one that works, I think. Let's go to the answer. Yeah, 7 over 2. So that would have taken me a while before I would have guessed that. Again, I would have used technology and all sorts of stuff to get the answer instead of doing what they did. But using the rational root theorem to solve word problems, looks like your teacher could assign 24, 33, 34, and 35. That's it for this video. Have a great day.